Okay, we are going to do an application problem now that involves bearings. So it says here an airplane has an airspeed of 150 kilometers per hour. It is to make a flight with a bearing of 70 degrees while there is a 25 kilometer per hour wind coming from 340 degrees, a bearing of 340 degrees. What will the plane's actual heading be? So it's basically taking this 70 degree 150 kilometer angle and adding it to this 25, or this one with the bearing of 340 degrees 25 kilometers per hour. Okay, so I'm going to do my little compass here. This is north. And so 70 degrees, it's going to measure down from here like this. And this is 150 kilometers per hour. Now it says that the wind, it doesn't have a bearing of 340 degrees. What it says is it's coming from a bearing of 340 degrees. When it's coming from that, it's a little confusing. I have to go around 340 degrees, so the whole thing is like 365 degrees, right? So this thing's going all the way around like this, and so that would be like maybe 340 degrees. So that's the bearing of 340 degrees, but it's coming from that direction. So really, it's gonna go in the opposite direction, like this, and then that'll be at 25 kilometers per hour. Okay, so now what we need to do is we got to figure out with these angles. So this is like 70 degrees. This whole thing around here is like 340 degrees. And so what we have to do is we have to figure out this angle between the two. Okay, so how are we going to do that? Well, if this is 70, then this here is just what? That's going to be 20 degrees. Now, if this whole bearing is 340, let me see if I can zoom in on here. So basically, like I was saying, if this is 70, then this is 20. If I go all the way around, and that's 340, okay, if I go all the way around but stop here, 3/4 of the way around, that's 270. So if I take 340 minus 270, that's going to give me, 340 minus 270, make sure it's going to give me 70 this angle here is going to be 70 degrees, okay? And so what that means is that this angle here is 70 degrees, because those two are vertical angles. So this angle and this angle, so from here to here, are vertical angles. So that's 70 degrees. And I think what that means is if we add these two together, it's actually 90 degrees, isn't it? I didn't realize that when I did the problem, but I think this whole thing would end up being a 90 degree angle. Okay? That whole thing is a 90 degree angle. So now what I'm going to do is I am going to make my parallelogram. So placing that on there and placing this on here, and then my vector is going to be the resultant vector. It's going to be the diagonal. My resultant vector will be the diagonal of this, but this is actually a rectangle now. That actually makes our job a little bit easier. So this is 25, that's 100. The resultant angle, I just need to use the Pythagorean theorem. So if I do that, then I get c squared. We'll let that be c. C squared is equal to 150 squared plus 25 squared. So 150 squared plus 25 squared. C squared is equal to 23,125. So my C would be the square root of that, which is approximately 152.1 kilometers per hour. And that would be my magnitude. And I didn't need the law of cosines there because I had a right angle there, and all of these would be right angles then. Okay? And then I don't need to use the law of sines because I want the resultant with respect to, it says what will the plane's heading be? So what I want here is I want the actual the bearing from here to here is what I want. Now I need to be really careful here because I do not want to assume that this here is the same as the x-axis, because I was almost thinking, oh, that's 20 degrees, but that's not. This is not the x-axis. So what I want here is I would like to get this angle from the resultant to here, and then how am I going to get the actual bearing? Oh, and then I'll just take 70 plus that angle to get the full bearing of this, if that makes sense. Okay, so I can use the tangent of this theta is equal to 25 over 150. So my theta is equal to tangent inverse of 25 over 150. So, tangent inverse of 25 divided by 150. I need to put that in parentheses though. And I get like 9.5 degrees. And so this would be the 70 plus 9.5 more. So it would be a bearing of 79.5 degrees. And that would be the heading of the plane. So when you take into account the wind and the speed and direction of the plane, it would be traveling at 152.1 kilometers per hour with a bearing of 79.5 degrees. Okay, so I didn't realize it when I chose this example, but these angles measured up to be 90 degrees. So if they don't measure up to be 90 degrees, then you would have to use the law of cosines and the law of sines to find the length and the angle. And that's probably what the next one is going to be like. So in the next video, we're going to do another one like this, and I'm going to give you a chance to do it before I actually work it out.